This is Nageswara, Assistant Professor of Physics, Government Degree College, Chintalapudi. In this presentation, I want to analyze the intensity of electric field due to the charge sphere using the Gauss law. Before going to the charge sphere, what is Gauss law? We know Gauss law states the total electric lines of force, that is total electric flux over a closed surface is equal to 1 by epsilon naught times the total charge q enclosed within the surface. So that pi is equal to total flux pi is equal to integration E dot ds, that is equal to E ds cos theta, that is equal to q by epsilon naught, where theta is the angle between electric field E and ds. Now, there is to determine the intensity of electric field due to uniformly charged sphere, there is three cases we will observe. One, if a point is outside the charged sphere. The second case is if the point is on the surface. Third case is if a point is inside of the charged sphere. In case 1, if a point is outside the charged sphere, for this purpose, we have to draw a charge sphere A having radius capital R, in which charge Q is distributed among the sphere and its center is taken as O. We know if we want to apply Gauss law, we want to draw a closed surface, that is also called Gaussian surface. For this purpose, we draw a Gaussian surface having radius small r, where r is the distance between center of the charge sphere and point P, where we have to calculate intensity of electric field which is lies at outside of the charge sphere. And the intensity of electric field is along the direction of OP, and ds is the small surface area on the Gaussian surface whose normal is always along the direction of electric field. So along this direction is also along this direction, and E is also along the same direction. Now, the intensity of electric field is directed normal to the surface area ds, where ds is the small area which is drawn on the surface of the Gaussian surface. For a small area ds, the flux a number of lines of force which is passing normal to the surface area ds, that is d pi is equal to E dot ds. So that is E ds cos 0, because the angle between E and ds is 0. Both of them are parallel. So we know cos 0 is equal to 1. So that the flux d pi is equal to E into ds. Now the total flux, how can we calculate? By integrating the above equation, we can get the total flux, total number of lines of force. So that after integration, the total flux pi is equal to integration E dot ds, that is equal to integration E into integration ds, that is equal to E into 4 pi r square. Sorry, there is no epsilon naught. Here, what is E 4 pi r square? That is integration ds is equal to 4 pi r square. This is equal to surface area of the Gaussian surface whose radius is small r. But we know according to the Gauss law, this total flux pi is equal to, that is E into 4 pi r square is equal to 1 by epsilon naught times of total charge enclosed within the surface, that is E into 4 pi r square is equal to q by epsilon naught. So that intensity of electric field E is equal to q by 4 pi epsilon naught small r square, or intensity of electric field capital E is equal to 1 by 4 pi epsilon 2 q by r square Newton per Coulomb. So this is the intensity of electric field at a point lies outside the charged sphere. Now how can we calculate the intensity of electric field at a point on the surface of the charged sphere? So this is the charged sphere having radius r and distributed a charge of plus q. So P is just on the surface of the charged sphere. So this is the point on the surface of the charged sphere. In this case, we know small r is equal to capital R. Capital R is the radius of the charged sphere. Small r is the distance between O and P. So when we apply small r is equal to capital R in the previous equation, that is 1 E is equal to 1 by 4 pi epsilon naught into Q by capital R square. Now what about third case? In this third case, if your point is inside of the charge sphere, so where capital R is the radius of the charge sphere and this is the radius of the charge sphere. And we have to calculate intensity of electric field at a point P inside of the charge sphere. So for this purpose, we have to draw a Gaussian surface with radius r dash, where r dash is the radius of the Gaussian sphere. So that is intensity of electric field E direction. The angle between E and ds I is 0 because both of them are in the same direction. Now r dash is the radius of the Gaussian sphere, that is Gaussian surface. Capital R is the radius of the charged sphere. And when we apply this, the number of lines of force or electric flux which is passing normal to the surface area ds, that is d pi is equal to E dot ds. But we know E and ds are along the same direction, so that the angle is 0, so that E ds cos 0, that is equal to E into ds. Now the total flux through the entire surface, by integrating the above equation, we can get the total flux. So the total flux pi is equal to integration E ds, that is equal to E into integration ds, that is equal to E into 4 pi r dash square, where r dash is the radius of the Gaussian sphere or Gaussian surface, that is integration ds is equal to 4 pi r dash square, that is the surface area of the Gaussian sphere. And if rho is the charge density, then the charge enclosed by the Gaussian sphere or Gaussian surface charge q is equal to, according to the charge q is equal to volume into charge density, q dash is equal to volume of the Gaussian sphere for third pi r dash q into charge density rho. So that where rho is equal to, we know total charge by volume, we know total charge on the charge sphere is capital Q, and volume of the charge sphere is 4/3 pi r cube. So that the charge density rho is equal to Q by 4/3 pi r cube. When we substitute into above equation, charge on the Gaussian surface or Gaussian sphere or within the Gaussian sphere, q dash is equal to 4/3 pi r dash cube into rho value is q by 4/3 pi r cube. When there is 4/3 pi is cancel each other, so that the charge within the Gaussian sphere q dash is equal to q into r dash cube by r cube. But from the Gauss law, we know the total flux pi is equal to integration E ds, that is E into ds is equal to q by epsilon naught, that is equal to 4 pi r dash square. So that E into 4 pi r dash square is equal to 1 by epsilon naught into r dash square cube by r cube, according to the above equation. so that the intensity of electric field capital E is equal to 1 by 4 pi epsilon naught into q r dash by r square Newton per coulomb. This is the intensity of electric field at a point inside of the charged sphere. So from the above equations, the intensity of electric field is varies inversely at the inside of outside of the charge sphere, and inside of the charge sphere the intensity of electric field is directly proportional to distance, that is E is proportional to r here inside of the charge sphere, and E is proportional to 1 by r square, that is outside of the charge sphere. So the diagram can be drawn like this. Inside of the charge sphere, that is proportional, so intensity of electric field increases proportional like this. Outside of the charge sphere, that is decreases like this. So this is the analysis of the intensity of electric field due to the charged sphere. Thank you.